And then for this question, they say, given a piecewise function, determine the value of m and n such that this function, it will be continuous in the interval of negative infinity to infinity. So when we get piecewise function, we draw out the interval. For us, easier to observe the changing of the function. So when x less than 2, for the first piece, it will be 2x for x less than 2. When we 2 until 5, it will be the function mx plus n. And when x more than 5, it will be 3 minus x. So when the function is stated here, they are continuous. This function is continuous from the negative infinity to infinity. Means that at the point of x equals to 2, where the graph changing from 2x to mx plus n, and where the point of x equals to 5. So we have to make sure this changing point of the function is continuous. So therefore, for the x equals to 2, to make sure the function is continuous, so we have to state out the condition of continuity, where the condition number 2, the limit when x approaches 2 must be active, means that limit approaches 2 from the left hand side must be equal to the limit approaches 2 from the right hand side to make sure this function exists, to make sure this limit of this function exists. At the same time, the condition 1 and condition 3 is said that limit must be equals to the point. So for the point f2, as we see it is x equals to 2, for the point x2, it will be equals to the limit from left hand side. So this will be the condition for the function to be continuous. Limit exists and the limit is equals to the point. So the point fall at left hand side, so we write it at the left hand side. Then we start evaluate this limit. As we substitute 2, we get 4. And here we get 2m plus n. So we get the first simultaneous equation. And then we proceed to another point here where the function also got changing when x equals to 5. So when x equals to 5, we want to make sure this continuity of this function, limit from approaches 5 from left hand side of the function must be equals limit x approaches 5 from the right hand side, and it must be equals to the point. So as the point fall on 3 minus x, so it will be equals to the point at 5. So for this limit right hand side, it will be equal to the point at 5. Then we evaluate this limit, we get 5m plus n equals to negative 2. So this is our second simultaneous equation in order to solve this. So we have similar term here. Therefore, we take equation 2 minus equation 1, so that 5m minus 2m, we get 3n. And n minus n can be eliminated. Then we can find our n. Then we substitute into either one equation, so I choose 1 to find n.